Okay, so we're here today at the Space at Manchester showcase, which is a really amazing opportunity where we're bringing in lots of collaborators from industry to learn about the research that we're doing in the field of space across the breadth of the entire university. And what's been really amazing to see is that this isn't focused on one discipline like engineering or science. We have people here from anthropology, we've got people here from geography, talking about the whole spectrum of research that we do.
What I've got in front of me here is SOAR. This is a model of our satellite. So in 2019, this satellite was transported on a SpaceX rocket up to the International Space Station. And then it was catapulted out by the smallsat launcher. And over the course of 9 months, it spent time getting lower and lower and going thicker and deeper into the atmosphere and doing experiments. And the experiments it was doing was using the fins on either side. Each will have a different material in them. To check which materials are good to resist the atmosphere, which materials are bad, and that gives us an idea of how we can coat our different satellites with different materials and make them last longer in lower orbits.
My name is Julia Riley. I'm Head of Education at Robotics Centre for Engagement, and we're here today because we're a route to the public for talking about space. We have 125,000 visitors a year to Robotics Centre for Engagement. We're a point of connection with the work at the observatory, the life science that happens there. We have 25,000 school children every year who come to visit us, and we aim to bring that spark of inspiration to the next generation, the future workforce for the space industry.
Hi, I'm Sharon. I'm from first year PhD at University of Manchester under Cradle program, and I'm doing my industrial PhD in space robotics. So this is one of my side projects, and we did it for European Space Agency. And this is mold system. It's a lunar excavator system with a beneficiator to assist the future lunar oxygen extraction. This system will excavate the lunar regolith, which you can see here. It's a lunar regolith simulant from European Space Agency, EAC-1. And this system will excavate the lunar soil, drop it into the hopper, which can store up to 10 kg. And this hopper will transfer the regolith into the beneficiation system. That beneficiation system vibrates and it can particle separate in 3 sizes. And the size of 100 microns and lower would be useful to extract the oxygen from it, where it will assist the future lunar missions.
Hello, my name is Catherine Holt. I'm from the UK Space Agency, and I've had the absolute delight of giving a keynote presentation this morning at Manchester University. I've been really impressed at the breadth of the expertise and the infrastructure resources available here, and the interest and the breadth of industry representation that they've got here. So I'm really excited to see what the future holds for the collaborations that are going to come out between the university and the local companies around here, and I wish both parties lots of luck.
There have been some really interesting discussions today related to from space sustainability through to the science coming out of the Jodrell Bank, for example, space anthropology, and feeding back through to the use of remote sensing for a whole range of development support activities. So we'd like to thank the visitors who came in today to learn more about what we do at the University of Manchester as it relates to space, and we hope this is just the start of our adventure together.